Hello students, welcome to my channel. Today we are going to start a new topic of basic concepts of chemistry. It is equivalent mass or equivalent weight, or it is called chemical equivalent, right? I will cover the topic in 4 or maybe 5 videos. This is a very fundamental topic. So तुम पेन और कॉपी लेकर तैयार हो जाओ. Are you ready? Alright, let's get started. I will try to make you understand the concept of equivalent mass from some basic ideas. Okay, let us take hydrogen as our standard element, right? Hydrogen as our standard element. We know the atomic mass of hydrogen is 1.008. So we take 1.008 part of hydrogen. Okay, 1.008 part of hydrogen. Now take another 6 elements which can combine with hydrogen to form different compounds, right? Let us take oxygen, let us take carbon, here it is sulfur, here say sodium, say chlorine, and let us take calcium. Now let us see what will happen when hydrogen will combine with these 6 elements separately, right? When hydrogen combines with oxygen, they will form H2O, right? In H2 molecule, 2 hydrogen atoms combine with 1 oxygen atom. So we can write atomic mass of hydrogen is 1.008. So we can write 2.016 part of hydrogen combined with how much? Atomic mass of oxygen is 16. So it is 16 part of oxygen, right? So this 1.008 part of hydrogen will combine with 1.008 part of hydrogen will combine with definitely 8 part of oxygen. So for the formation of H2 molecule, 1.008 part of hydrogen will combine with, we can write of course 8 part of oxygen, right? So this is 8 parts, right? This is 8 parts, okay? Now what will happen when hydrogen combine with carbon? So carbon and hydrogen forms different compounds. Catenation property of carbon is effective there. So they can form different alkanes, alkenes, alkynes, etc. But we just take only the simplest example. Carbon and hydrogen combine together to form the simplest molecule. It is nothing but CH4. It is methane, right? So now what will happen in methane? For the formation of methane, we can write 4 into 1.008, isn't it? We can write for the formation of methane 4 into 1.008 part of hydrogen will combine with 12 parts of carbon, right? So this 1.008 part of hydrogen will combine with how much? This is 3 parts of carbon, isn't it? So we can write 1.008 part of hydrogen combined with 3 parts of carbon. This is 3 parts by weight, of course. 3 parts weight of carbon combines with 1.008 parts of hydrogen to form methane molecule, right? So this 1.008:3 is their weight ratio, okay, to form the molecule methane. Okay, going forward to the next case. When hydrogen and sulfur combine together, they form definitely hydrogen sulfide, H2S molecule. And what will happen in H2S? Of course we can write 2 into 1.008 part of hydrogen combines with atomic mass of sulfur is 32. So this is 32 parts of sulfur, okay. So 1.008 part of hydrogen will combine with, of course, 6 parts of sulfur. So we can write 1.008 part of hydrogen combines with 16 parts of sulfur to form H2S molecule, right? What will happen when sodium and hydrogen combines together? Sodium and hydrogen combine together to form sodium hydride, right, NaH. And of course this is 1:1 ratio, atomic ratio is 1:1. Here the atom ratio is 1:1. So 1.008 part of hydrogen combined with atomic mass of sodium, this is 23 parts. We can write 23 parts of sodium, right? Okay. Hydrogen and chlorine combine together to form the simplest molecule, of course, HCl. Okay, and this is 1:1 ratio, so we can write 1.008 part of hydrogen combined with 35.5 parts of chlorine, right? This is 35.5 parts. Okay, and lastly calcium and hydrogen combine together to form hydrolith. This molecule is known as hydrolith, calcium hydride. So here we can write 2 into 1.008 part of hydrogen combined with 40 parts of calcium. Atomic mass of calcium is 40. So of course 1.008 part of hydrogen combined with 20 parts of calcium, right? So we can write here 20 parts. Okay. Till now we have found what happens when hydrogen combines with these elements to form the separate compounds, and in which mass ratio hydrogen will combine with these elements, right? Now the case will be very interesting. Look. Now carbon and oxygen combine together to form the molecule carbon dioxide, right? Of course this is according to valency, right? Now what happened in carbon dioxide? Look, in carbon dioxide molecule we can write 12 part of carbon, we can write in simplest form. We can write here in simple form 12 part of carbon combines with oxygen 16 into 2, that is 32 parts of oxygen, right? So this 3 part of carbon, combines with how much? This is 8 part of oxygen, right? Okay, so look at here. So to form carbon dioxide molecule, 3 parts of carbon combines with 8 parts of oxygen. Okay, so this is 3:8 ratio. Carbon and oxygen combine together in the ratio of 3:8 to form carbon dioxide. Okay, what will happen when carbon and sulfur combine together? They form definitely carbon disulfide. This is CH2 molecule, and of course here we can write the 12 part of carbon combined with sulfur 32 into 2, this is 64 parts of sulfur, right? So 3 parts of carbon with combined with definitely 16 part of sulfur. Look at here, this is your 3, it is your 16. So carbon and sulfur combine together in the mass ratio of 3:16 to form the compound carbon disulfide, right? Looking forward, what will happen next? When sodium and sulfur combine together, they form the compound, we know this is sodium sulfide, Na2S, right? And in Na2S, what will happen? We can write 23 into 2, this is 46 parts of sodium, 46 part of sodium combined with 1 sulfur, this is 32 parts of sulfur. So 23 parts of sodium will combine with 16 part of sulfur. Look at here, this is your 23, this is your 16, it is your 23 and this is your 16. So they combine with the same mass ratio by which they combine with hydrogen separately. Okay, looking forward, what will happen when sodium and chlorine combine together to form obviously sodium chloride? What will happen? Of course, 23 parts of sodium combined with 35.5 parts of chlorine, right? What will happen when calcium and chlorine combine together to form calcium chloride? What will happen? We can find 40 part of calcium combined with 35.5 into 2 parts of chlorine. So 20 part of calcium will combine with 35.5 part of chlorine. So the happenings are very interesting here. We can combine any element with other, but keep in mind that group valency of all the elements must be considered because a valency factor is involved there. We will see later. Okay. Look, we can combine oxygen with sodium to form sodium oxide, right? Na2O. We can combine carbon with chlorine to form CCl4, carbon tetrachloride. We can combine sulfur with calcium to form calcium sulfide. But in all the cases, the mass ratio of the elements must be equal. Okay, look at here, sodium 23 into 2, this is 46 part of sodium will combine with 16 part of oxygen. So 23 part of sodium will combine with 8 part of oxygen. Okay, so when sodium and oxygen combine together, of course they combine in the mass ratio of 23:8. Okay, when carbon and chlorine combine together, definitely 12 part of carbon combine with 35.5 into 4 parts of chlorine. So 3 parts of carbon will combine with 35.5 parts of chlorine, right? So of course carbon and chlorine combine in the ratio of 3:35.5 to form the compound carbon tetrachloride, and likewise calcium and sulfur combine together to form calcium sulfide in the mass ratio of course 20:16. So the things look very interesting here, isn't it? So of course there is some magic in the numbers of 1.008 part of hydrogen, 8 part of oxygen, 3 parts of carbon, 16 part of sulfur, 23 part of sodium, 35.5 part of chlorine, or 20 parts of calcium, or these parts will be different for different elements. Okay, so these parts are actually known as the equivalent mass. This mass amount of these elements are known as the equivalent mass or equivalent weight of the elements. Okay, so what is equivalent mass? Equivalent mass is a particular mass of a particular element or a compound when any element combines with other elements or displaces other element from their compounds. They combines in the ratio of their equivalent mass. Okay, or equivalent mass of the element displaces equivalent mass of other element from their compounds. Okay, so this is the concept of equivalent mass. This is the fundamental idea of equivalent mass, right? So equivalent mass is a wide concept, but literally it is defined with respect to 3 different elements. The standard element are hydrogen, oxygen and chlorine. As you know, atomic mass or molecular mass of elements are defined with respect to 3 scales. One is 12C scale, other is 1H scale, and the other is a 16OH scale. Similarly, equivalent mass of elements are defined with respect to the 3 scales. One is hydrogen scale, other is oxygen scale, and the other one is chlorine scale. Equivalent mass of other elements are defined with respect to hydrogen, oxygen and chlorine scale, right? Let us define the equivalent mass with respect to hydrogen, oxygen and chlorine scale. So we can write equivalent mass of an element X, this is equal to mass of the element or weight of the element. W represents the weight of the element. So this is Wx. Wx is the weight of the element which combines with W part of hydrogen into 1.008, right? So equivalent mass of an element X, this is equal to mass of the element divided by mass of hydrogen with which the element combines into 1.008. You can simply calculate it by a unitary method. Say Wh gram of hydrogen combines with say Wx gram of the element, and 1.008 part of hydrogen combines with obviously Wx divided by Wh into 1.008. Okay. So this is the mass or this is the weight of the element which combines with 1.008 gram of hydrogen, right? So the definition is the mass of the element combines with 1.008 part of hydrogen is known as the equivalent mass of the element. Okay. So this is the mass of the element divided by mass of hydrogen into 1.008. And similarly we can write equivalent mass of an element X. This is equal to mass of the element X divided by mass of oxygen into 8, isn't it? 8 part is the equivalent mass of oxygen. Of course, O stands for oxygen, I can write here. So the mass of the element combines with 8 part of oxygen is known as the equivalent mass of the element. Similarly, in chlorine scale we can write mass of the element X divided by mass of chlorine into 35.5. This 35.5 is the equivalent mass of chlorine. So the mass of the element combines with 35.5 parts of chlorine is known as the equivalent mass of the element. Okay. So we can apply this formulae when the mass of the element and mass of hydrogen or oxygen or chlorine has been given. Okay. But also look at here, this hydrogen, chlorine and oxygen, these three are gaseous. So sometimes the volume of these three elements have been given. Okay. So from that volume we can calculate the equivalent mass of the element also. So when the volumes of hydrogen, oxygen or chlorine have been given, these formulae can be modified. Okay. So we can modify these formulae with respect to the volume of hydrogen, oxygen and chlorine, right? So look at here carefully. We know at STP volume of, we can write volume of 2.016 gram of hydrogen is 22.4 liter. Of course at STP, isn't it? Okay. So we can substitute this 1.008 gram of hydrogen by its volume. Okay. So the volume of 1.008 gram of hydrogen is obviously 11.2 liter at STP, of course. Okay. Now modify this equation. Look what will happen. This one equal to, this is the mass of the element X, Wx above, this is say volume of hydrogen in liter and at STP, standard temperature pressure into 11.2, right? So this is other example, other definition of equivalent mass of the element. Look at here, this is dimensionally correct. This volume of hydrogen is taken in liter at STP, and of course this 11.2 is in liter. So if the mass of the element given and the volume of hydrogen with which this mass of the element combines or displaced, we can apply this formula to calculate the equivalent mass of the element, right. In case of oxygen, we can write volume of 32 gram of oxygen. 32 gram of oxygen is 22.4 liter at STP. So here 8 gram of oxygen is taken at standard. So 8 gram of oxygen combines with, of course, 5.6 liter, isn't it? Liter at STP. So we can modify this equation also in the form as, say, this one is a W of X above volume of oxygen of course in liter, volume of hydrogen, of course hydrogen is gaseous, hydrogen and oxygen are diatomic gases, so volume of hydrogen, of course hydrogen is gaseous. Now volume of oxygen in liter at STP into 5.6, and of course 5.6 is in liter, okay. Now, and if we modify this equation of chlorine, we can write here, we know volume of 71 gram of chlorine is 22.4 liter at STP. So 35.5 gram of chlorine is 11.2 liter at STP. So we can again modify this equation, this one, as the mass of X divided by volume of chlorine gas, this is Cl2, in liter at STP into 11.2, okay. So these are the 6 definitions of equivalent mass, right. So we can apply the first 3 equations when the mass of the element and mass of hydrogen, oxygen or chlorine have been given, and we can apply the last 3 equations when the volume of hydrogen, oxygen and chlorine have been given, okay. Now we will learn how the equivalent mass is related to our known parameters like atomic mass, molecular mass, etc., okay. Now we will derive the relationship between equivalent mass, it is represented by E, capital E, and atomic mass, which is represented by capital A, right. So let us start from the definition of valency. आप बोर तो नहीं हो रहे हो? हेलो, सुन रहे हो क्या? Okay, let's go. As you have learned in your class 7 or 8, the definition of valency. What is the definition of valency? Let's say the valency of an element is V, right? So what is the definition of valency? In class 7 or 8 you have learned, let's say ammonia, okay. The valency of nitrogen is 3 here. This is ammonia, say nitrogen and hydrogen, the valency of nitrogen is 3 and the valency of hydrogen is 1. So the exchange occurs, isn't it? So this is the Na3. So 3 is the valency of nitrogen and 1 is the valency of hydrogen, right? So we can say the number of atoms of hydrogen combines with 1 atom of the element is known as the valency of that element, isn't it? So if V is the valency of any element, we can say 1 atom of this element will combine with V atom of hydrogen atom, okay. So from here we can write, let valency of an element, say the element is X, valency of an element X is V, is capital V, right? So we can write V atoms of hydrogen. V atoms of hydrogen combines with one atom of the element, X. Okay, so now multiply this V number of atoms with Avogadro number. So we can write V into 6.022 into 10 to the power 23. This number of atoms of hydrogen, combines with 6.022 into 10 to the power 23, this number of atoms of the elements, right? Now look, this is the number of atoms of hydrogen. Now the mass of Avogadro number of atoms of hydrogen is the atomic mass of hydrogen. So we can write V into 1.008 gram of hydrogen. This gram of hydrogen combines with say this is A is the atomic mass of the element, so we can write a gram of the element, a gram of X, isn't it? Atomic mass of hydrogen is 1.008 and 1.008 gram of hydrogen contains this number of hydrogen atoms. So the mass of this number of hydrogen atom is 1.008, and similarly mass of this number of atoms of the element X is its atomic mass. So in the second line it was the number of atoms, and in the third line it is the mass of these elements. Okay, so therefore we can write 1.008 part 1.008 gram of hydrogen combines with A by V, this gram of the element, X. Now recapitulate the definition of equivalent mass. With respect to hydrogen scale, the mass of the element combines with 1.008 part of hydrogen is the equivalent mass. So this A by V is actually the equivalent mass of the element X, right? So we can write from the definition of equivalent weight, from the definition of equivalent weight, from the definition of equivalent mass. From the definition of equivalent mass E, equivalent mass is represented by E, we can write, of course, E equal to A by V. That is equivalent mass equal to atomic mass divided by valency. Okay, so this is actually or of course A equal to E into V, that is atomic mass equal to equivalent mass into valency. So this equation holds good for different elements and ions, of course. So this is a very important equation. In this video we will now discuss some calculations using this equation, and in the next video we will discuss how equivalent mass of different compounds are related to their molecular mass. Let's see some examples. For monovalent or univalent elements like alkali metals, lithium, sodium, potassium, rubidium, cesium, etc. we can write equivalent mass. This is equal to atomic mass, because the valency of these elements is 1, so equivalent mass equal to atomic mass, right? Now for divalent atoms, for divalent elements like say beryllium, magnesium, calcium, strontium, barium, etc. Barium, zinc, of course, etc. We can write equivalent mass. This is equal to atomic mass by 2. They are divalent, so the valence is 2. Say for example, the equivalent mass of magnesium, this is nothing but 24 by 2, this is 12. Okay. Equivalent mass of calcium, this is 40 divided by 2, this is 20. Okay, and so on and so on. Number 3, for trivalent atoms, trivalent elements like boron, aluminium, etc. Equivalent mass, this is equal to atomic mass by 3. For example, equivalent mass of aluminium, this is nothing but 27 by 3. This is 9, right? So far so good, but there are many elements which have variable valency. So for the elements having variable valency, this valency factor is changed, so the equivalent mass is changed. For example, number 4, for elements having variable valency, say for example, copper, it can produce cuprous oxide, it can form cupric oxide also. So in cuprous oxide, the equivalent mass of copper, this is equal to atomic mass by 1. So this is nothing but 63.5, isn't it? But in case of cupric oxide, the equivalent mass of copper is atomic mass divided by 2. So this is 63.5 divided by 2. This is 31.75. Okay. So if the valency of the element is changed, the equivalent mass of the element will also be changed. Okay. Let us take the example of 2 different reactions. Say for example, we know Fe reacts with HCl to form ferrous chloride, FeCl2 plus hydrogen gas. Okay. So in this reaction, the equivalent mass of Fe, equivalent mass of iron will be atomic mass divided by 2, because in this reaction Fe, iron is oxidized from its 0 oxidation state to +2 oxidation state. Okay. So here actually ferrous iron is present, so the equivalent mass of iron is nothing but 56 divided by 2, this is 28. Okay. But take the example of say when iron reacts with red hot iron reacts with chlorine to form ferric chloride FeCl3, right? Okay. So in this reaction Fe is oxidized from its 0 oxidation state to +3 oxidation state, or ferric ion is present there. So here equivalent mass of iron equal to atomic mass of iron divided by 3. This is 56 by 3. So this is 18.67. Okay. So the conclusion we can make from here that the equivalent mass of an element is not a fixed quantity. It varies with V. Actually, atomic mass of the element is a constant. So we can write equivalent mass is inversely proportional to V. Okay. So E proportional to 1 by V. This is important. As the valency of the element increases, its equivalent mass decreases. Okay. So that's it from this video. We will meet in the next video of equivalent mass. Bye bye for now.